Here's the most annoying thing about web scraping. You write a scraper, it works perfectly, and then one quiet morning the website changes a single class name and your whole pipeline silently breaks. In this video we'll fix that for good. We'll build a scraper that notices when it breaks and uses an AI model to repair itself, with no human touching the code. In this tutorial we'll build a self-healing web scraper in plain Python. The idea is simple. A normal scraper depends on fixed selectors, little rules that say where the title or the price lives in the page. When the site's markup changes, those rules stop matching and you get empty data. Our scraper will detect that, hand the fresh page to a language model, and ask it to work out new selectors on the spot. Then it saves what worked and carries on. Here's the plan. First, a scraper that keeps its selectors in a small file instead of hard-coding them. Second, a validation step, because self-healing is impossible if the code can't tell that it's broken. Third, the heart of it, a heal step where we send the current page to a language model and get back fresh selectors. Fourth, a loop that retries with those healed selectors and, when they work, saves them so the fix sticks. And finally, we put the whole thing on a schedule, so it can break and repair itself while you're asleep. This is the entire system on one screen. A scheduler wakes the scraper up. It fetches the page, extracts fields using the selectors we already have, and validates the result. If every required field came back, we save the data and we're done. That's the happy path along the top. But if validation fails, the dashed path, we hand the live page to the model, it rederives the selectors, and we loop straight back into extraction with the patched rules. Notice there's no arrow going to a human. That missing arrow is the whole point of the video. You'll need a few things. Python 3.10 or newer and an API key for a language model. 2 small libraries, requests to download the page, and BeautifulSoup to parse it. A model that can return clean JSON, because we'll ask it for selectors in a structured shape. And one thing that isn't code but matters just as much, permission. Only scrape sites you're allowed to, respect the robots file, and keep your request rate gentle. A self-healing scraper runs on its own, so being a polite one is part of the design, not an afterthought. Step 1. Install the dependencies. Requests to fetch the page, BeautifulSoup 4 to parse the HTML, and the OpenAI client for the healing step. You can swap that last one for any model client that returns structured text. Nothing about the design is tied to one provider. 3 small libraries, and every one of them you'd use in an ordinary scraper anyway. The self-healing part is not a heavy framework, it's about 40 lines of your own code on top of these. Step 2, and this is the design decision that makes everything else possible. We do not hardcode the selectors. Instead, we keep them in a small JSON file and load them at runtime. Fields is the list of things we actually care about here: title, price, and availability. Because the selectors live in data rather than in code, the model can rewrite that file later without anyone editing or redeploying the program. A traditional scraper bakes its selectors into the source, which is exactly why fixing one always means a human and a code change. We just move the knowledge somewhere the machine can reach it. Step 3. Fetch the page, the ordinary part. We download the HTML with a timeout so a slow server can't hang the whole run, and we set a clear user agent string that identifies our bot honestly. Calling raise for status means a server error becomes a real Python error instead of us quietly trying to scrape an error page. Keep this function boring and reliable, because everything downstream assumes it either returns real page text or fails loudly. There's no intelligence here yet, just a clean, well-behaved download. Step 4. Extraction. We parse the page once, then walk through our selectors, one CSS selector per field, and pull the text out of each matching element. The key detail is what happens on a miss. If a selector no longer matches anything, select 1 returns nothing, and we deliberately store a none for that field instead of crashing. That none is a signal, not a failure. In a moment, that little none is exactly what tells the system a selector has gone stale and healing is needed. Most scrapers throw an exception here: we turn the miss into information. Step 5. Validation, the sense of self-awareness that makes healing possible. It's tiny, but conceptually it's the most important function in the file. We simply check that every required field came back with a real, non-empty value. If the price is missing, or the title came back empty, isValid returns false and we know the page has drifted out from under our selectors. A scraper that can't tell the difference between good data and empty data can never fix itself, because it never knows anything is wrong. This one line is the difference between a scraper that breaks silently and one that knows it broke. Step 6. The heart of the whole idea, the heal function. When our saved selectors stop working, we send the model the current page and the list of fields we want, and we ask it to return fresh CSS selectors as JSON. 3 things make this reliable in practice. We trim the HTML so we don't blow past the model's context or waste money on a giant page. We force a JSON response, so we get back a clean object we can parse instead of a paragraph of prose. And we describe the fields by meaning, title, price, availability, so the model matches on intent, not on the old markup that just broke. The model is acting as an on-call engineer who reads the new page and writes the patch. Step 7. We wire it together into the self-healing loop. We fetch the page, load whatever selectors we have, and try to extract. If that's already valid, we skip healing entirely. Most days cost you nothing extra. But if it's broken, we enter the loop, the model re-derives selectors, we extract again, and we check once more. The moment we get valid data, we save those selectors, so tomorrow's run starts from the fix and never calls the model at all. And notice max heals. Without a hard cap, a genuinely dead page could loop forever and burn through your API budget. If we're still broken after a couple of attempts, we raise, because a scraper that fails loudly is far safer than one that spends money in circles. Step 8. A single entry point. A tiny main file pulls in the target and the fields, runs the scraper, and prints the result as neat JSON. Now the whole system is one command, Python main.py, which is exactly the interface we need for the final step. Anything you can trigger with one clean command, you can hand to a scheduler and forget about. That simple front door is what turns a script into an unattended worker. Step 9. The payoff, put it on a schedule. One cron line runs the scraper every morning and appends everything, including errors, to a log file. Now here's what actually happens over time. On a normal day it uses the saved selectors and the model is never called. On the day the site changes, validation fails, the model quietly writes new selectors, the run succeeds, and the fix is saved all before you've had your coffee. On a server, a systemd timer does the same job with cleaner logging and automatic restarts. This is the moment your scraper stops being something you maintain and becomes something that maintains itself. Before you point this at the real world, a few guardrails that separate a toy from something you'd actually run. Cap the number of heals per run, so a broken page can never drain your budget. Save a copy of the page you healed on, because when you do want to debug, the original HTML is gold. Send yourself an alert whenever a heal fires. It's not an error, but it's a useful signal that the site changed. Always respect the robots file, rate limits, and terms of use. Automation is not an excuse to be rude. And sanity check the healed data. If the model returns a price of nothing or a title that's an entire paragraph, treat that as still broken rather than blindly trusting it. Self-healing should make your scraper more robust, never less careful. Let's recap the whole build. We kept selectors in a file instead of in code, so they can be rewritten at runtime. A one-line validation step gives the scraper the self-awareness to know when it's broken. The heal step hands the live page to a language model and gets back fresh selectors. The loop retries with those selectors and saves the ones that work, so every fix is permanent. And a schedule plus a few guardrails turn the whole thing into a scraper that quietly maintains itself. That's maybe 50 lines of Python standing between you and never fixing a broken selector by hand again. That's a complete self-healing scraper, start to finish. The full code is linked in the description, so you can point it at a page you're allowed to scrape and watch it repair itself the next time that site changes. If this saved you a future headache, subscribe, there's a new AI build every week. Thanks for watching, and I'll see you in the next one.